Welcome back once again, dear students, to the balancing of redox equations.
Taking another example for you, Cr2O7 2 negative plus 3 it's a SO3 2 negative. It is changing to Cr3 positive plus SO4 2 negative. Now this reaction we have to balance in acidic medium. We have to balance this reaction in acidic medium. So let's see how we have to balance. First step, determine the oxidation state for each of them. So here the oxidation state is 6, for oxygen is -2. For sulfur you will have here 3 2 just 6, that will be 4 here. Oxygen will be -2. Chromium ionic form +3. Sulfur you will have here 8, so this will be -6. This sulfur it will be +6. That side will change, so it will be +6, and oxygen you will get -2. So now next step, we have to see that where is the increase and where is the decrease. You see the 6 is getting to 3, so here the decrease is by -3, and the sulfur it is becoming 6, 4 to 6, so here it is an increase of +2. Then now the thing was that our increase and decrease that should be equal, so this one we have to multiply by 3 and this one we have to multiply by 2, then only the increase and decrease will be equal. Then here you see the increase and the decrease we have to make it equal, so this side we have to multiply by 2, then that became equal, and this is multiplied by 3, the equation is multiplied by 3, so here I have to multiply by 3, then the increase and the decrease will become equal. The increase and the decrease now became equal. You see the decrease was from 6 to 3 and the increase was from 4 to 2, means 4 to 6, so the decrease was the increase was +2 and the decrease was -3. To make them balance I multiplied them by 2. Then this was your second step. Now the next step says that balance all other atoms except hydrogen and oxygen. Now let's see, balance all other atoms except hydrogen and oxygen. See how many chromium, 2 chromium, 2 chromium, that is balanced. 3 sulfurs but 1 sulfur, so multiply by 3 here. Then now the next step, oxygen, now we have to see that the total number of charge. Then what is the total charge on chromate? It is -2. Here on sulfite it was -2, but 3 sulfites are there, so that will be -6, so that is equal to 8 here. On the right left side your total charge is 8. Now come to the right side. Here 1 chromium is 3 positive, so 2 will be 6, plus here this is -2, so that will be -6, so that is equal to 0. It means that both sides the charge should be 0. Now here I have -8. Now this -8 I have to make it 0. Now I say that the reaction is carried out in acidic medium. Now when the medium is acidic we have to use H positive protons. Now why I have used 8 H positive? Because my total charge was -8. -8 plus 8 will become 0. Now I have to balance the number of hydrogen. Now for this I have the full liberty to use water molecules. I am using water molecules on the right side. Now here I had 8 hydrogens, so 4. Now we have to balance the number of oxygen on both the sides. Now the formula says that if your balancing is correct, your oxygen will be automatically balanced. You see 7 oxygens are there, plus here you have 9 oxygens, so in total you have 16 oxygens. Now come to the right side, you have 3 4s are 12 oxygens plus that 4, so you have 16 oxygens. Now all other atoms are balanced, so your final balanced equation is Cr2O7 2 negative plus SO3 2 negative, you have a 2 here, plus 8H positive becomes 2Cr3 positive plus 3SO4 2 negative plus 4H2O. This is your showing this example once again to you. The example was Cr2O7 2 negative plus SO2. This is changing to Cr3 positive plus SO4 2 negative, and the reaction is occurring in acidic medium. Acidic medium. Now how to balance this reaction? Now for balancing this reaction, first step is that we have to find out the oxidation state of each atom. We have to find out the oxidation state of each of the atoms. So let's begin it. Now I hope that you all are familiar how to find out the oxidation state, so I'll not use much time for finding out the oxidation state, and I'll be directly writing the values of the oxidation state. You see Here if you are calculating the oxidation state for chromium, you will get the oxidation state of chromium as, here you will get 6, here you will get -2, and for this sulfur if you are checking, you will get 4, this will get -2, it has become +3. Here for sulfur you will get here 6, and for oxygen you will get -2. Now let's see this chromium, the oxidation number has decreased. The oxidation number of chromium, it has decreased here. So the decrease is, it is by, the decrease is by -3, and for sulfur it is an increase of +2. This is the increase. Now as the rule says that the increase and the decrease, that should be equal, so for that we have to multiply this by 2 and we have to multiply by 3 here. So let's multiply. Where the increase was beginning, we have to multiply by 3 this one, and we have to multiply by 3 this one. Similarly we have to multiply by 2 this one, and we have also to multiply by 2 this one, but since this chromium atom, it is already 2 here, so we don't need to multiply here. So up to here we have done. Then now the next step is that we have to see the total amount of charge which is present on the right side and which is present on the left side. Let us see. Here on chromate the total charge is -2. On sulfite the total charge will be 3, and this SO2, it is there, SO2 is neutral, so here your charge is 0 here. SO2, it does not have any charge here, so this charge will be 0 here. This question I have taken directly from your book, so this charge, it will be 0 here, so this is plus 0. So here the total charge became -2, and here the total charge is 2 3 times is 6, plus this will be 3 2 times is -6, so that is equal to 0. Now both side I have to make it equal. The charge should be equal on both side. Then I said that for balancing a reaction, we have the liberty to use hydrogen and water on both the sides. Means if you are adding water to this side, you have to add acid to this side. Now since the reaction is occurring in acidic medium, we have to use H positive here. Then if you are using H positive here, we have to use water on this side, and this is inherent. If you are using, means in acidic medium always the acid is used in the reagent phase, reactant phase, and H2O is added in the product phase. Now here H positive, now the total charge was -2, so I need 2 positive charge, then only it will become 0, so I will have to use 2H positive. Now see the number of hydrogens and oxygen. See here, two hydrogens, and now let's see the total number of oxygen here. It is 7 plus 6, that is equal to 7 plus 6, 13 oxygens. Let's see here, 3 fours are 12, and plus 1 oxygen there, so that will be equal to 13 oxygens. So in total you have 13 oxygens, and this is your final balanced reaction, which is Cr2O7 2 negative plus 3 SO2 plus 2H positive, changing to 2Cr3 positive plus 3SO4 2 negative. This is a complete balanced reaction, plus H2O is there. This is a complete balanced reaction. Now these all were done under acidic medium. Now I'll show you one example which is done under the basic medium. So I'll show you that one now. This is also, I'm taking it from the book directly. I'm taking it from the book. The reaction is your MnO4 negative plus iodine negative, and this is changing to MnO2 plus I2. Now here the steps will be just same, nothing will change here. First of all, we have to find out the oxidation number for each of the atom, and once again I'm repeating the same thing. I hope that you all are now already practiced with this, how to find out the oxidation state. Here the oxidation state will be -2, here this will be +7, this will be -1. Again here if you are finding out, then this will be, it will be, this will be -2, this will be 4, and this will be 0. Now this reaction is occurring in basic medium this time. This is occurring in basic medium. Then now let's see how the numbers are changing. If you are focusing on iodine, this is becoming, it has been increased. The increase is by +1. and if you are concentrating on manganese, it was earlier +7, now it has become +4, means there is a decrease of 3. There is a decrease by 3. Now we have to balance the increase and the decrease, then that one we can do only by multiplying a value. If I am multiplying by 3, then there will be an increase, there the increase and the decrease will be equal. 3 is increasing, 3 is decreasing, so now here I'll have to multiply by 3, so I'm multiplying it by 3. Then now if I am multiplying, we have to multiply by 3, but now you see, if we are multiplying it by 3, then what will happen? My total iodine atom, that will become 6. That will become 6. But on the left side, I had only 3 iodine. So I have to multiply by that number, that will give me the resultant as 3 iodine. So here I will multiply it by 3 by 2. Then see, if I am multiplying it by 3 by 2, then we will get, both side you will get 3 iodines, so this is now balanced here. So the first step, it is done here, and now the next step is that we have to see the total amount of charges. Now here I have MnO4 negative plus 3I negative, and this is changing to MnO2 plus 3 by 2 I2. I know this 3 by 2 is seeming quite absurd to you, but it is like that only. It is done in this way. Now the reaction is carried out in the basic medium. Now when the reaction is carried on basic medium, we have to use OH minus on the right hand side. We have to use this one on the right hand side. In one acidic medium, we have to use H positive on here. Now the next thing is that we have to see the total amount of charge which is present here. Then what is the charge total? Here it is -1, then plus 3 iodines are there, so it will be -3, that will be equal to -4 here. The total charge is -4 on the left side, means on the left side you have your total charges -4. And if I am looking at the right hand side, on the right hand side you have, this is 0, this is also 0, then only -1, so here the total charge is -1. Now I have to balance the charge on both sides. Then now for this, what I'll have to do here, we need -3 charge more here. We need -3 charge more, then only it will become equal. Now here you'll say that we will use H positive here, but you cannot use H positive here because the reaction is carried out in basic medium. Now if we are to make both side equal, adding if I am adding -3 charge more, then we'll get -4 here. So if I am doing here 4, then if 4 is there, then you see now the total charge will become -4. Then now it is balanced. Now the charge is balanced. It is a bit complicated, yeah, I understood, but you see, I'll write it once again for you all. It is MnO4 negative plus 3 iodine negative changing to MnO2 plus 3 by 2 I2 and plus 4 OH negative. This is your reaction till now. Okay. Then now the next step, we have to balance the hydrogen balance. Now for balancing the hydrogen, left hand side we don't have any hydrogen. We don't have any hydrogen here. But on the right side we have how many hydrogens? We have 4 hydrogens. Now if we have to balance this one, we will have to use water. So let me add water here. Since I don't have place here, so I'm adding it here. Anywhere you can add that one. You can add it anywhere. You can add it anywhere. So you see, now I'll be adding water to the left side, so H2O I have added it here. Now how many hydrogens were there? 4 hydrogens, but here I have only 2, so I'll multiply this one by 2. Then now last step is that you have to see the number of oxygens. Now this step says that if your balancing is correct, your oxygen will come automatically the correct one. You see how many oxygens are here? 2 oxygens plus 4 oxygens. In total you will have 6 oxygens here. And here how many you will get? You see, 2 oxygens are present in Mn plus 4 oxygens, so you got 6 oxygens. So this is your complete balanced reaction, including the water molecule. This is your complete balanced reaction in a basic medium. This is a complete reaction in a basic medium. Now this was the first method. The first method was based on your oxidation number change method, where I have done certain examples for you, like 4 or 5 examples I have done. Now we will do the another method, which is your ion electron method. Now in this ion electron method, how we have to do, you see here. Similar to the previous one, here also we have certain steps. Now what are those steps? See, first step is that step 1 says that we have to split the reaction in two parts. In two parts, we have to split the reaction in two parts. Then, and those two steps will be, where the first step will be for oxidation, and the second step it will be for reduction. Second step will be reduction. We have to split the reaction into two parts, where the first part will be oxidation and second part will be reduction. Now comes the second step. The second step, that is step 2, that will be your balancing the atoms other than oxidation and oxygen and hydrogen. We have to balance all atoms except oxygen and hydrogen in the half reactions. In the half reactions. Now what is this half reaction? It will be clear when I'll do the example. In the half reaction, all atoms except hydrogen and oxygen, we have to balance it. Now the third step, the third step the, the third step we will in the third step we will balance the third step we will balance hydrogen and oxygen by adding H positive or water as much as it is required. Means we have to balance H2O, and we have to balance hydrogen and oxygen by using H positive and H2O. We can use as many number of H positive as many H2O. We have the full liberty we can do. And the last step here, step number 4, will be that we have to balance the charge here. We'll have to balance the charge. And for balancing the charge, what we will do is that we will add electrons. For balancing the charge, we will add electrons to the reaction. Now how it is done, I'll be showing you examples. Now the step 5, the last step will be, step number 5 will be that we will add the two reactions. We'll step now by listening to the steps, it will, nothing is to be done. Now we have to apply this on some example, and I'll lay it down. You practice it, then it will be more clear for you. Now at present I'm taking one example, and the example is of here the example I'm taking it directly from your book. The example is MnO4. NCRT question book is there. MnO4 negative plus SO2, it is changing to Mn2 positive plus HSO4 negative. Now this is the reaction here. Now here you want to be mentioned that whether it is acidic medium or basic medium. It is not like that. Now first of all, we have to see the oxidation number first. First of all, we have to see the oxidation number here. Then once again, we have this MnO4. Now here the oxidation state is 7. Here it is becoming plus 2. Now this is, now see, here in the earlier compound it was plus 7. It has become plus 2 here. It means that this is the reduction. There is a reduction. Plus 7 was there. It became plus 2. And similarly for sulfur, here for sulfur the oxidation state, it was 4. Here the oxidation state is 6. It means that now there it is oxidation. There is oxidation. Then now see here, you have to find out the oxidation state by yourself. Now that is the reason why I'm not using much time here. I have directly written the oxidation states here, because so long we have been doing the oxidation state. Now you see here the reduction was done. Now here what did I say in the first step? In the first step I said that split the reaction in two parts, where first will be oxidation and second will be reduction. So now we have to split it. Now the splitting will be done as this one. You see, first step is, first step we have to split them. Then where is the reduction occurring? We'll write here reduction. Now where is the reduction occurring? Reduction is occurring MnO4 negative has become Mn2 positive. This is my reduction reaction. And next one is oxidation. Now in oxidation, where is the oxidation occurring? SO2 has become HSO4 negative. Now this the first step is done. Now first step is done. Now what was the second step? The second step says that we have to balance all atoms except oxygen and hydrogen in the half reaction. Now half reaction means these two are the half reaction. The one which we have splitted, this is a splitted reaction, they are known as a half reaction. Now the second step says that we have to balance all other atoms except hydrogen and oxygen. Then let's see here. Manganese 1, manganese 1. We are not concentrating on oxygen at this time. Sulfur 1, sulfur 1. So everything is balanced. So we need not to see anything here. We need not to do here. Now the third step, what does the third step says? The third step says that we have to balance hydrogen and oxygen. Now we have to balance hydrogen and oxygen in them. Then let's see. The first step is MnO4 negative and Mn2 plus. Now we have 4 oxygens here. Now we have to say that here you see, here I had 4 oxygens, but on the left side, on the right side, we don't have any oxygen. Then for this, I will have to use water molecules, that is H2. Now how many oxygens were there? 4. So I'll have to use 4 oxygens here, 4 molecules of water. Then only my 4 oxygen will be balanced. But now here, here 8 hydrogens are there. Now see, when we have balanced oxygen, the extra hydrogen came into the being and came into the picture, that is 8 hydrogen. Now to balance this one, I will have to use 8 hydrogens here. Why 8 hydrogens? Because 8 hydrogen in extra we have here. Now similarly come to this reaction. Now here hydrogen and oxygen balanced. Now here you see, left hand side we have 2 oxygen, here it is 4 oxygen. Now here 1 hydrogen, here no hydrogen. Now we have to balance it. Now how to balance? If I have to use hydrogen here, then we will have to use water. If you have to use H2, then now you see H2O I have added. Now if I have to balance the number of oxygen here, then here H, how many oxygens were there? 4. Here I have only 3. So now if I am using 2 here, you see what will happen? Then the oxygen is balanced. Now but what about the hydrogen? Now if hydrogen, you see how many hydrogens are there? Here we have 4 hydrogens, but here I have only 1 hydrogen. Now I have to balance hydrogen. So for balancing the hydrogen, I will add H positive. See, everything is going according to these steps. What was said that we have to balance hydrogen and oxygen by using H positive and H2O on either of the side where it is required. So that is what I have done here. I have balanced the reaction using water and H positive on both the sides. Now you see oxygen and hydrogen is balanced on both sides. Now what is the next step? What is the next step? The next step was that we have to balance the charge now. Step number 4. 4 says that we have to balance the charges now. Now let's see what is the total amount of charge present in the reaction. Now see what charge is present, we have to see. For the first reaction, let's see what is the charge here. We have -1 plus 8, that is equal to +7. Now on this side it is only +2 charge. Now we have to balance it both side. Now for balancing the charge, we have only the liberty to use electrons. We have to use only electrons here. We can use only electrons. Now here my charge was +7 and here it is +2. Now we know that electrons carry negative charge. Then if I am adding 5 electrons, then 7 minus 5 will be 2. If I am adding 5 electrons on the left side, you see, if I am adding 5 electrons here, 5 E negative, then what will be my total charge? Here it was, you see, 5 electrons and 1 negative charge. This will become 6, thus 8 positive, so it will become +2 charge here, and now it will be balanced with the right side. We have to balance with, we have used 5 electrons here. Now similarly come to this side. Now here what will happen? Here the charge on the left side in the oxidation half is 0, 0. There is no charge. Right hand side it is minus, plus, -1, that is +3. It is equal to +2. This become +2. Now if I have +2 on the right side and here we have 0 charge, it means that on the right side I will have to make the charge 0 here. Then for that I will have to use, earlier it was +2, I'll have to use 2 electrons here. Then now the thing comes into the picture. What is the important thing here? Now this number of electron in both the oxidation and the reduction half, that should be equal in both the reaction. I'll write it once again. Okay, you see, for the reduction part, for the reduction, we got 5 electrons. We got here 5 electrons and MnO4, 5 electrons plus MnO4 plus 8H positive, changing to Mn2 positive plus HSO4 negative plus HSO4 negative. And for the oxidation part, I have got H2O plus SO2, H2O plus SO2 changing to HSO4 plus 3H positive, HSO4 plus 3H positive, 3H positive plus 2 electrons, plus 2 electrons. Now let's see what are there. With water I have 2 here and rest is balanced. With water I have 2 here, and here it was not HSO4 negative, it is water here. You see, it was water. See, with Mn2 positive I have 4 molecules of water, so I'll be writing here 4 molecules of water, 4H2. And now what I say that in these reactions, this number of electron in both the halves reaction, that should be equal. Then this 5 and this 2 can be made only equal if we multiply this equation by 2. Suppose if we are considering this one as equation 1 and this one as equation 2, then we have to make the number of electrons equal. That is only possible if you multiply equation 1 by 2 and if you multiply equation 2 by 5, then only it is possible. Then let us multiply them. Let's multiply. What will happen? You see, the first equation will become we are multiplying by 2, so this will become 10 electrons plus 2 MnO4 plus 16H positive, changing to 2 Mn positive plus 8 molecules of water. I have done nothing, just I have multiplied by 2. The complete reaction I have multiplied by 2. Similarly here I'll multiply by 5 here, so this will become 10 molecules of water plus 5 molecules of SO2, and that will become, here it will become 5 molecules of HSO4 negative plus 15 molecules of H positive plus 10 electrons. 10 electrons. Now after this we have to add these two reactions. There the final step was said. The final step here says that we have to add the step number 5 was that we have to add both the half reactions. So now when you add both the half reactions, when we are adding both the half reactions, you see this 10 electron, this 10 electron, they are present on two different sides of equation, they will cancel out. Now whatever we are left with, we are going to write that one. Now you see, we will be left with 10 molecules of water plus 5 SO2 plus 2 MnO4 plus 16H positive. This is just whatever it is there, they are unlike terms, so I am not adding them, I am just directly writing them below. This will be changing to see here, this is changing to here 2 Mn positive plus 8 H2O plus 5 HSO4 negative plus 15 H positive. This is the reaction. Now from here, whatever the like terms are there, you bring them together on one side. I'll show you. I'm erasing this one. If you want to see it, you can read the video, means you can go backward by double swiping it, double clicking it, or you can cut it. Now you see. Now when I will add this to what I said, that whatever the like terms are there, bring them together. So when this 8H2O will come on this side of the equation, with this 10H2O, this 8H2O will be subtracted. So you will be left with 2 molecules of water plus this 5SO2 is there, no like terms. So that will be 5SO2 plus 2MnO4, no more MnO4 here. So that will be 2MnO4, then plus the 16H positive. When this 15H positive will come this side, it will become plus H positive, and this will change to 2Mn positive plus 5HSO4 negative, and this is your final balanced reaction. Now this was the method for which we used in the means ion electron method. This method is known as ion electron method because we have used electron and we have used ions. So this is the second method of balancing. Now using this technique, you have to balance all the remaining reactions. If the method is mentioned, you have to mention, you have to do by ion electron method. Now that was the last important topic of this chapter, where we discussed the balancing of equation by two different methods, where the first method was your oxidation number method and the second method was your ion electron method. You can only understand it if you do practice it by your own, by taking some examples. If yet you have any more problems, you can contact me.
Thank you for watching the video up to here. Have a good day.